And implicit in that is the fact that if you participate in the meeting, you will if you participate in the meeting,
You'll go out and come back in.
Yeah, you'll show up on YouTube as well. So, can you all still hear me?
Yes.
Okay, good. All right, I'm just admitting people as they come up into the waiting room.
Okay.
Ah, there you are. Okay, God. Had to find
Nice
the
to
right
meet you.
icon to get everyone back.
So anyway, regarding the church and the YouTube, so we have enough bandwidth at the church to simultaneously use Zoom and YouTube. And then there's a setting in Zoom where you can send your Zoom feed directly to YouTube. And I've started doing that so that I don't have to record and then upload the video subsequently. One of the other challenges is we've started through our local humanist group. Some of you may have seen the messages on YouTube or the invites on Meetup. We've started a thing called Sidewalk Science, and we have some bona fide scientists that join us a couple times a month. And we take science questions and talk about science topics. So I have a couple of physicists, Mike Albro, you know, at least from the church, but there's another physicist who's a active member of our humanist group, or not our humanist group, the American Humanist Association, and a biologist who recently wrote a book published by the Humanist Press. She joins us. A personal friend of mine who's also a physicist joins us, and then Joanne and I. So anyway, we've got this Sidewalk Science initiative that's happening, and we hope to eventually expand that to be kind of a national program publicized by the American Humanist Association, where the general public can join and talk about science. The problem with that is that we don't want to host a Zoom call with 100 people in it.
Right.
For many different reasons, some of which are probably all of which you can imagine. So part of the technology challenge that we're facing is how to set up essentially call queuing for a Zoom meeting. And Dave, my husband and technology guru, Dave, believes he's found a mechanism where you could run 2 Zoom meetings simultaneously and then use a piece of bridging software to pipe the output of one Zoom meeting into the second one. And that first Zoom meeting then would be sort of a holding area where he could greet people and vet their questions and make sure that they're not there to harass people and whatnot. So anyway, we're trying to get a lot of moving pieces of technology to work for our Zoom meetings, and getting YouTube and Zoom connected was our first challenge, and we did it really for the first time 2 weeks ago during the Science Sunday, and it was probably 10 or 15 minutes into that program of Mike's that we actually got the feed working correctly.
Steve Darwin.
Hello.
Hey.
Hi. This is Peter Marinelli. My first time in any of these things. I wanted to ask you, have you consulted at all with the folks who did the, I'm not sure if it was based in Washington, D.C., but the all-day seminar, I think it was last weekend.
Yeah, the AHA seminar, right?
Yeah, I'm just wondering, because they had quite a few people that they claim were on what I believe was Zoom. And I'm just wondering if they have some arrangements that we're not aware of, or.
Yeah, that's a great idea, Peter. Thank you for raising that possibility. I just took a note about that. They may have solved this problem previously. And they are officially a sponsor of our other science initiative, the Sidewalk Science that happened yesterday.
Okay.
They provided our local humanist chapter with a small grant and we're using that to pay for our Zoom channel, for example. But
Okay,
yeah,
that's neat.
I'll contact them and see if they've got some technical expertise that might help. Yeah, Dave, go ahead, Vicki.
Terrific.
I've been going to occasionally this group called Recovering from Religion Monday nights, and they often have very close to 100 people, and it works quite well. And then they usually have a short speaker and a Q&A that we handle through chat, and afterward, those of us who want hang out in smaller numbers.
Yeah. I'm thinking about joining those meetings too. As an aside, most of you are aware of the fact, if not all of you are aware of the fact that, oh, whoops, I've got somebody else waiting here. I got to let him in. Most of you are aware of the fact that humanism explicitly rejects supernaturalism and claims of magic and miracles and gods and whatnot. And my focus as a humanist, my particular passion is on science, and also certainly on issues of human equality and human well-being. You can find scientists that concentrate on the science so much and really have no particular concern or passion about human well-being in general. But humanism, I think, is a nice way to merge compassion and an interest in human equality, human rights, with deference to what science can tell us about what's real and possible. So anyway, regarding the RFR, the Recovering from Religion folks, one of the questions that I notice crops up again and again in a lot of the programs that I watch on YouTube about religion and atheism and recovering from religion and humanism. One of the recurrent themes that I see in the questions is about science. Well, how can you explain the beauty of the world, and how can you explain, how stars work and whatnot, without some miraculous explanation? And science has been able to answer, to a greater or lesser degree, and in most cases a greater degree, every question we've ever posed about how anything works. Now, there are some things that are less well answered, like human consciousness, and that is probably the most complex phenomena that we've ever encountered in the universe, is the phenomena of human consciousness and cognition. And so we've only been at this science thing for a couple of hundred years, and it's not particularly, or maybe 500 years, it's not particularly surprising that there are still things that we haven't completely unraveled or solved. But in any case, the relationship with recovering from religion is, I've thought about trying to encourage people with scientific knowledge to join the volunteer group for recovering from religion, to provide not only an ear and a heart for people who are in a difficult transition period in their philosophy and the implications of that in their personal lives and whatnot, but also to bring into the discussions some of these answers that people who were raised in a religious context may not know anything about. Stellar nucleosynthesis, for example. How did the elements come to be? And other questions. So I think the Recovering from Religion Foundation does a great job of providing emotional support and intellectual support. And I'd like to encourage people to help them and see if knowledge about science is also something that is a gap that we help cover. Let's see, I think it's been a few minutes since anybody else has requested access here on my queue, so I think everybody is likely here that is going to join today. Welcome. This is our regular twice monthly Science Sunday. During the summer, I've typically had these kinds of just chats so that I don't have to prepare a program. And we may continue to do something like this throughout the year also. I find them really edifying. It's a great way to connect with people. Some of you have seen the lectures that Mike and I have given over the past few years, and especially during the spring and summer as we've given lectures, we're speaking to an empty room. It's just the two of us and a camera operator. And it's hard to get a sense of feedback. It's hard to get a sense of whether you're connecting with people and explaining things properly. So I really like this forum. At least combining the Zoom meeting capability with those in the future is something we will do. And then maybe also these kinds of chats. So I want to start off our topics.
I have a
today.
question for you.
Oh, sure. Go ahead.
I have a question for you. When you've had those sessions where nobody was in the audience, so to speak, did you pipe those to YouTube and then encourage by some kind of posting people who hadn't seen a Science Sunday event to look at the YouTubes and get interested?
Yeah, we do have a YouTube. It's so I have several skills, I think, but among those, I do not count publicist or marketing. So,
Okay.
We have a meetup page. The Humanists of West Suburban Chicagoland has recently changed our name to the Prairie State Humanists. And we have a meetup page where we reference our meetings. If it's a science-related topic, I also publish that on the Chicago Science Field Trips meetup most of the time. And but other than that, other than my personal Facebook feed, I haven't been doing a lot. Again, there's an opportunity there, I think, to plug in more with the American Humanist Association, especially as we're doing more online events to help publicize these to a wider audience. But I have mixed feelings about that in the context of Science Sunday specifically. The Science Sunday initiative started as a program at our local Unitarian church. And over the years, we've been able to draw in people whose primary focus is humanism and science, and they don't necessarily participate in the other church programs. And that's perfectly fine with us, with Mike and I. Or Mike and me. But on the other hand, I'm not sure I want to throw the net wider for our Science Sunday, which is kind of a local program. I'm not sure I want to, invite a lot of people.
I see the issue.
Yeah.
Yeah, I see the issue.
Yeah, but certainly for Sidewalk Science, we want that to be a much larger program. And so your advice about reaching out to the AHA for technical help is appreciated, but we're also intending, once we get the technical bugs worked out, we're going to ask the AHA to help publicize our event in the magazine and the website and whatnot.
Okay.
All right. So good. Regarding science topics, last time we did this was a month ago, I think, and I made a terrible error. Somebody had raised the issue of some interesting discoveries on the sun. Somebody said, I think it might have been Bill, or it might have been Bob Wonderlock. I'm not sure who it was, but somebody raised the issue of these bonfires or campfires on the surface of the sun that had been recently discovered. And like Norm in Cheers or other bellicose know-it-alls, I went off on a tangent about spicules, which are a known sort of like bubbles of hot material on the surface of the sun. And spicules have been known about for a century or so. Well, indeed, there was something new discovered that is akin to a campfire. They're much smaller than a spicule. A spicule is about the size of a continent, which is tiny in the scale of the sun. But these campfires are just, I'm looking over at a news page I have about them. They were much smaller. It looks like hundreds of miles, thousands of miles, rather than 2,000 or 4,000 or 5,000 miles like a continent. So they're new, small, little specks of heat on the sun, and I think if I do this correctly, I should be able to show you all. If I share my screen. So can you all see this?
Yes.
So these arrows in this image are pointing to these little campfires on the sun. These are little bright specks. So they're embedded in larger convective cells, and the larger cells are what I call this. Well, everybody calls the spicules, but these tiny little bright flecks are like little campfires on the sun, and that was just recently discovered. So whoever brought that to my attention, I failed to give it the attention it was due, and I misinterpreted what the news story was. So
how do they get named campfires? It's not the kind of thing you'd use for a marshmallow roast.
Yeah, I don't know that scientists have decided whether or not they're going to get some other name. Sometimes these kinds of names like campfire flares stick. So we'll have to wait a year or so and see if the powers that be come up with a different name. I've got if you see my browser I have open here, I've got 10 or so tabs open with interesting science news from the past couple of weeks. But before I do that, I'm going to open up the floor to see if any of you have heard of interesting science news stories. Maybe one of them will relate to something I already have up here and we can talk about it, or maybe it'll be something new. So does anybody have some interesting science news they've heard about recently?
I came across an article just a couple of days ago that kind of disturbing in the context of climate change, because they've done a study and they're now claiming that Greenland is past the tipping point, that its melt rate is exceeding what it can possibly, that even if the carbon dioxide increase stopped today and it was returned back to where it was 50 years ago, it wouldn't stop the disintegration of the ice cap. And,
right.
It's basically going now. We've done it in the case of Greenland. We've set the activity in motion, and it's dumping huge amounts of fresh water into the ocean now.
Wow.
So,
yeah, I had that one queued up, and it is a very disturbing story. It's exactly what I've read is exactly what you recount. But
yeah,
that's
they're predicting now that it's 3 feet on sea rise by the end of the century, just from Greenland.
Yeah, nothing we can do about it.
Yeah.
Along that same line, I think I read some time back that quantity of water coming into the system might have an effect on the current.
Yes.
Mm-hmm.
And that could screw up a whole lot of other things.
Yeah, absolutely. So there's if I'm remembering its name correctly, there's a thing called the thermohaline current. Maybe they've changed its name. That's the name I remember. And it's a conveyor belt of ocean currents in the Atlantic. And it's one of it is the primary reason why Europe is warm. If you look at the latitude of Britain and Paris and Berlin and some of these other large European cities, they're actually where Canada is in the North American continent. And one of the reasons they're warm is because of this big circulating current that's driven by temperature and changes in salinity. And the fear is that if you dump a bunch of fresh water into the North Atlantic, it could even turn off this thermohaline circulation, and that would just be devastating for the climate of Europe. Notwithstanding the fact that the whole globe is warming, it might plunge them into a glaciation period. There's evidence that happened once before. There was something called Glacial Lake Agassiz in North America. Have you folks heard of that?
Mhm.
And that lake was much larger than the Great Lakes are currently, and it was held back by an ice dam that was the remnants of the Laurentian ice sheet from the last ice age. And when that ice dam thawed and burst, this tremendous amount of fresh water from Lake Agassiz spilled into the North Atlantic, and it's been correlated, that event has been correlated in geologic climatological records from things like mud core samples from natural lakes and whatnot. That's been correlated with a sudden decrease in temperature in Europe. So this idea has precedence that flushing a bunch of water into the North Atlantic, fresh water, could disrupt global climate in a way that has no direct relationship to the whole carbon dioxide issue.
Wow.
I heard a talk on that topic. It had been 15 or 20 years ago that they were talking about how the melting of Greenland can upset the Gulf Stream and throw Europe and make Europe cold. This is 15 or 20 years ago, so this is not anything new that I know of. Also, I saw that. Oh, sorry, I just lost my chain of thought. All right.
That's all right.
Sorry.
I just want to speak up. You're right. I think they just in the last year discovered that the point where the water actually goes down to make the circulation is to the east of Greenland. They always thought it was to the west end of Greenland.
Oh, really? That's interesting.
And but there a sad thing, because usually scientists actually underestimate things. A Swiss scientist, Konrad Steffens, Steffens, lost his life this week on Greenland. He was gone out to check data and he fell through.
Fell into a crevasse?
Into a crevasse, and they can't recover him.
Oh, no.
Wow.
So, but he was about 67, but he was one of the leading scientists on glaciers, particularly in the Antarctic and in Greenland.
Oh, wow.
Hmm.
You know, I've mentioned it many times before in shameless, selfless plugs, selfish plugs, but I'm writing a couple of science books. And my first book, I talked about this a couple of times over the summer. One of the things that I discuss is scientific disposition, the kinds of character traits that are helpful to maintain a scientific disposition. And you don't have to be a scientist to have this sort of disposition. But one of the traits I list is courage. You know, scientists are often some of the people who go into some of the more dangerous environments that we mere mortals fear to tread in. You know, the deep trenches of the ocean. I believe most, if not all, of the astronauts have PhDs and are scientists and engineers. So the bravery required of scientists to bring us information about places that are inhospitable and mysterious shouldn't be underestimated.
Also,
Right.
There was a study out a year or so ago, and I talked a little bit with Joanne about it, because it blew my mind. You always think of gravity is holding us down on the ground.
Mm-hmm.
But they're talking about the glacier on Greenland, the mass of it. And the mass of it actually pulls the ocean toward it. And so if the entire glacier would go, the ocean would sink not sink, but the water level in the ocean around Greenland would drop 30 to 50 feet.
Oh, wow, that's
Okay.
fantastic.
Joanne brought up, well, you also have the rebound, but that's without the rebound. Using a
Right.
satellite. So what it means is all that water, when they say it'll raise the ocean levels by 20 feet, that's an average worldwide. Well, around Greenland, and they said within 2,000 kilometers, they wouldn't see much difference along their shores as far as sea level rise. All that water would head south.
I see. So around Greenland, the water's kind of piled up because of the mass of Greenland.
It's like the moon pulls the waves in when it's out.
Yeah. And then when that mass of ice goes away, sea level will lower around that geography, but then there's more water in the ocean, so the ocean will rise. And you're saying that it's sort of an equilibrium effect for at least.
Since it's the Earth is spinning, it tends to go more toward the equator, or
Okay.
And plus the southern hemisphere has much more ocean than we have up north. So 60% will end up in the southern oceans just to even it out.
Yeah. So does that mean that the sea level effect, I assume that when we quote things like, a 3 foot or 5 foot rise due to the Greenland ice sheet melting, I assume that all that's taken into account, the gravitational differential and whatnot?
All we see is the average. So they just did a rough average of the world. Okay, there's enough here to raise the oceans 20 feet in the world. But when you get into the science of how it gets distributed, it's not equal.
Interesting.
And they're saying it's not like northern Europe, because all this water is going to go south. They're not going to see much rise on their shorelines.
Because of Greenland.
Like down in the Caribbean, those islands may be underwater or something.
Fascinating. And certainly the South Pacific.
Right.
A lot of the island nations in the South Pacific are just barely keeping their land above water. Not that they're expending any effort at it, obviously, but you know what I mean.
And just a plug, because I've watched this guy a couple of times. I kind of look at a lot of climate and global warming stuff and what we're trying to do to mitigate it. There's a YouTube website called Just Have a Think that I would recommend going and see. He puts out videos. The guy's out of Great Britain, I think. So you don't get as much political BS in as we get here in the US. And it's science and maybe some engineering. I just watched one today on recycling lithium batteries. So he goes into where the lithium comes from and the process that they use to recycle it and who's doing what in it. So there is some positive information in there in the sense that, hey, someone's doing something.
Right.
One of the other factors in that article on Greenland was that they have already been able to measure that it's having an effect. The change in mass is having an effect on the magnetic field around Greenland. So that's another variable in all of this, is changing Earth's magnetic field distribution.
I guess ice is diamagnetic, right?
Yeah, and I think just the gravitational effect too is having all kinds of indirect factors involved.
Huh.
So it also affects not just Greenland, but the melting of the glaciers everywhere throws off onto the Earth. And so the axis is moving. So what was used to be true north, now the axis is over here because the Earth is spinning a little more this way than this way, because it moves based on how the glaciers are melting.
Yeah, it's like what do you call those? Ice skater changing the configurations of one arm, but not both. And that'll cause a change in the axis of spin. So if all the mass piled up there where Greenland is now distributed more evenly across the Earth and the oceans, then that changes the axis of rotation of the Earth a little bit.
And it applies to all glaciers. I mean, what's happening in Himalayas, what's happening in North Canada, whatnot.
Yeah, I don't remember the statistic. Maybe one of you does, but I think I recall that there's this general idea that Greenland has a significant percentage of the ice on Earth, and then most of the rest of it is made up from Antarctica, and all of the glaciers combined on the other continents is a almost negligible fraction of those two others.
That's probably true. I mean, the two largest glaciers are in Antarctica, and Greenland's number 3.
Mm-hmm.
But they're still huge.
Yeah.
But even the melting of the smaller glaciers affects the balance.
Right.
I mean,
so I've got another related to that. Let me share my screen again. So speaking of other glaciers, I don't know if you'll be able to hear this. The sound isn't as important, but this is a video taken by some a teacher and a student who were doing some mountain climbing in Switzerland, and they saw this. Can you all hear this or not?
No.
Okay.
but we
So
see
this is just a. So this is 8,700 feet above sea level, high in the Swiss Alps, and they captured this this glacier just, you know, the edge of it falling apart. And they're saying that 2020, at least in Europe, is going to be the hottest year on record. So another record that we're all sad to see broken. And then there was a resort, I forget if it was in France or Switzerland or Italy, but somewhere around the Alps, there was a resort that was evacuated because they had a fear of what do you call those, snow slides, avalanches. Yeah.
Avalanche.
Hey, Scott, I don't know if everybody lost you or, but I didn't get your audio for a bit there.
Oh, can you hear me now?
I can now.
Okay.
Did anybody else lose audio?
No,
No.
I didn't. No.
Well, go ahead then.
Okay. Let's see what other climate related stuff. Here's that article about Arctic sea ice lost by 2035. So this isn't just Greenland. This is all of the Arctic sea ice, some of which historically has persisted throughout the summer. Scientists are now speculating that by 2035, just 15 years from now, there will not be sea ice in the Arctic.
Yeah, I remember in the 60s when I think it was the atomic sub-Polaris busted through, and it was about, what was it, 3 meters or so thick at the North Pole. And now it's open water.
Right.
So the
It's going to be tough on the polar bears.
Yep.
yeah, they're toast.
So changing, hopefully, to less depressing topic. I want to talk a little bit about Betelgeuse. So some of you may recall from last year that there was a report about the star Betelgeuse, which is a red giant in the constellation Orion, and it dimmed significantly and unexpectedly about a year or two ago. And scientists were wondering what the heck's up with Betelgeuse. So one of the interesting things about Betelgeuse is that it is so big and so nearby as stars go that we can actually use telescopes that humanity has built to zoom in on the surface, to take a picture of the surface of Betelgeuse. The pictures aren't real high resolution, but we can see it as a splotchy surface. And one of the big mysteries was, why did Betelgeuse suddenly get dimmer? And the current, some recent observations have led scientists to conclude that Betelgeuse essentially belched out a giant plume of gas and plasma, and that it subsequently cooled. Well, at this life cycle stage of a giant star, it's making a lot of carbon. Well, what happens when you have a lot of carbon and you cool it off underneath under plasma temperatures? It tends to condense into what we would call soot, and it's very black and dark. So they think that the star Betelgeuse essentially burped out a cloud of material that cooled off and became a dark cloud of soot between Betelgeuse and Earth, and that's why it seems to have dimmed. Recent, as in this summer, observations of Betelgeuse indicate that it may have done something similar again this summer, but we won't know for certain until, from our perspective here on Earth, Betelgeuse is far enough away from the sun, so we progress into the fall and winter so that we can aim terrestrial telescopes at it again to get more information. But to wrap up that thought, Betelgeuse is nearing the end of its life as a star and is definitely going to explode as a supernova. Question is when? Will it happen in our lifetimes? Will it happen after human civilization has ended? In tens of thousands of years? Nobody knows for certain. But it is one of the most studied stars in the sky because of its behavior and the fact that it's at the end of its life as a regular star.
Hey, Scott, kind of following that, how I presume this has been observed many times, but could you kind of go through the description of the end of the life of a star, and has it actually been, I mean, the instant or relatively short period of time when it ceases to exist as I guess all of its fuel is utilized?
Yeah, sure. I'll cover that briefly. So stars produce light and energy because the pressure is so intense at their cores that it causes the temperature at the core to rise up. So pressure and temperature in many contexts are sort of the same phenomena with a different name. It's a little bit of a simplification, but we'll go with that. So the pressure and temperature is so high at the center of stars that atoms smash together and can stick. And until, well, a star can use different fuels and release energy by making atoms stick together. So it first fuses hydrogen into helium, and then helium into carbon and nitrogen and oxygen. And then it can make silicon and sulfur and so on until it makes iron. Once you have a stellar core that's full of iron, smashing iron atoms together to try to coalesce them into another heavier molecule, even if you just try to add on a simple hydrogen a nucleus to an iron nucleus, it actually takes more energy to do that than it releases. So once you get to iron, nuclear fusion is no longer able to liberate energy. Well, if you can't liberate energy as a star, you essentially die. That's when a star dies, is when it stops producing energy. Stars like the sun are not heavy enough to make their cores hot enough to fuse anything beyond carbon, nitrogen, and oxygen, maybe a little bit of silicon. But our sun and stars like it will never get to the point of making iron. They just won't be hot enough. So they will turn off their nuclear fusion energy generation processes before they get an iron core. In any case, when a star stops producing energy, the temperature and pressure has percolated out from the core up until that point and has been holding off the outer layers of the star to keep it from collapsing in. Once that energy pump turns off, the outer layers outside the core can collapse. And many times this leads to a pulsation. So if the outer layers collapse in, that heats up the core again. Well, it might get hot enough that it starts nuclear fusion once again. So you have a lot of stars in the sky that are variable stars, and their variability is explained by this physical dynamics between compression and heating, and then they get hotter, and it's hot enough that it puffs them up again. And as they puff up, they cool off, and then they get so cool that they start collapsing, and they collapse and they get hot again, and then it's hot and it puffs them up. And so you can have stars that just puff up and puff, sort of like a pressure cooker, you know, the thing on a pressure cooker that goes, right? It's the same kind of concept with variable stars. Well, eventually every star will run out of the ability to make new atoms by fusion. And there's a couple of ways that stars end their life. There are four ways that stars end their lives at that point. One is that stars like our sun that aren't particularly heavy as stars go will end with this compact ball of carbon, nitrogen, oxygen nuclei. And the electrons will sort of be like an ocean. There'll be a highly conductive, highly magnetic ball called a white dwarf. White dwarfs probably have a crust of diamond. So white dwarf stars are white hot, but they're cooling off over time because they're not producing or generating any more energy. But they're probably, to a large extent, made of diamond, out of carbon that is crystallized. If you get up to about, once you get beyond about 1.4 times the mass of the sun compacted into a white dwarf, then you get into neutron stars. And the electrons that are stripped off of atoms inside a white dwarf are actually crushed into the nucleus and combine with protons. When you combine a proton with a neutron in a roundabout way, you get when you combine an electron and a proton, you get a neutron. But there's already neutrons in the nucleus of an atom. So you end up with this giant ball of neutrons. And then the third way is that even if you're left with neutrons and the star is more than about 2.6 times the mass, the leftover material is about 2.6 times the mass of the star, our sun, no known force of nature can keep it from collapsing further, and it turns into a black hole. The fourth way that stars can end their lives is they can completely blow themselves to smithereens so that there's no stellar remnant left at all. When a star like the sun ends its life, it turns into a nova. So it becomes bright and hot as it's generating carbon and nitrogen, which releases a lot more energy per unit volume than the fusion of hydrogen. And our star will get bright and hot and big, and it'll get so big that eventually the outer layers of our sun will just puff out and make a sphere of gas and dust that expands in space. I'll show you a picture of what that looks like for some stars that have already done this. So can you see my screen, Bill?
Yes.
So these are pictures of things called planetary nebula, where right at the center, so this is a good example, right at the center is the remnant of the star that existed there, but it's now cooling off and no longer doing nuclear fusion. And instead it's puffed out the outer layers into these beautiful rings of material that waft off into space. So that's the way a star like our sun will end its life. And then if it's heavier than our sun, when it runs out of fuel and gets an iron core, instead the star will blast itself apart in a violent explosion that can outshine all of the other stars in a galaxy for several days or weeks. And that's what's called a supernova. So here's one of the most famous supernovas. It's called the Crab Nebula.
Mm.
And so this is a star that has literally shattered itself. In the process of shattering itself, it releases so much energy that it actually takes those iron molecules, some of them that were left behind, as well as carbon and hydrogen and helium and other material in the star, and it can impart enough energy to those elements that elements heavier than iron are synthesized. So in its dying final days, a supernova generates many of the elements heavier than iron that we see around us on our planet. And the life cycle of a star is such that as a star transitions from burning hydrogen into burning helium, each successively heavier atom that is used as nuclear fuel corresponds to a shorter burn time. So hydrogen burning could last for billions of years, like it does on our sun. And then eventually our sun, when it turns into a red giant and gets hotter and puffs out because it's now using helium as its main fuel, well, that helium will only last for a couple of million years. And then maybe it'll do a little bit of carbon and nitrogen and oxygen fusion to make silicon, and that'll only last for perhaps, and I'm making this up, I don't remember the exact number, but it could last for 1,000 to 100 years. And with a really giant star like Betelgeuse that we talked about a moment ago, the last stages of its life as it's synthesizing iron from silicon could last just centuries rather than thousands or millions or billions of years. And when all that fuel runs out, there's a shock wave, like a sonic boom that's powerful enough to rip the whole star apart, and that's the supernova. And that can happen in the period of hours or even minutes. So the very last stage of the life of a supermassive star can transpire over the course of hours or minutes, even though the star has been around for a billion years.
So has that been observed, or is that
No. That's one of the cool things about Betelgeuse. So typically astronomers capture images of supernovas after they've gone kablooey. And there are telescopes that are dedicated to looking for supernovas in other galaxies. So a typical galaxy like the Milky Way is expected to have about one supernova a century. Well, the last time we had a supernova in the Milky Way was about 300 or 400 years ago. So we're well overdue for a supernova. And it just so happens that one of the stars closer to us, Betelgeuse, is a likely candidate. So scientists are paying a lot of attention to Betelgeuse. They don't want to miss that moment when it goes kablooey. Most of the surveys of the night sky looking for supernovas in other galaxies, they only know about them when they happen, not right before they happen. So we don't get to see the whole process of the last days or minutes. But with Betelgeuse, assuming that humanity is still around when it puts on its last show, it'll be quite spectacular to observe and safe. We're far enough away from it that it'll be safe.
I heard that from Earth, it will be about as bright as the nighttime moon.
Right.
So you would be able to see it even during the daytime.
Mm-hmm.
That would be cool.
Yeah, I just hope it doesn't happen in the summertime, because in that case, Betelgeuse would be obscured by the light of the sun. All right, speaking of supernovas and whatnot, that was a wonderful, Bill, I don't know, I'm going to have to send you some cookies or something, because you did a great job of providing a segue to another topic I wanted to cover.
Well, thank you.
Yeah. So the most recent close by supernova happened in 1987. And it was a supernova in a nearby dwarf galaxy called the Large Magellanic Cloud. And I don't necessarily need to go into details about all that. The interesting thing is that that supernova must have left behind something, maybe a neutron star, maybe a black hole. And recently, so you see this news story is dated July 30th. Recently, scientists have uncovered some tantalizing evidence that a neutron star does indeed exist now in the center of that supernova remnant from 1987. So 33 years ago, a new neutron star was born, and we saw it happening. And then the final astronomical piece of news I have to share is this notion of something called a black dwarf supernova. So there's no pictures of this, but I want to share with you these numbers. The scientists who came up with these estimations say that these are the largest numbers that have ever happened to come out of a scientific prediction. So the black dwarf supernova may occur in 10 to the 1,100th year. Now, that's like, quoting from the article, it's like saying the word trillion 100 times. So it's like the first black dwarf supernova, and I'll explain what that is in a minute. The first black dwarf supernova expected to happen in our universe will happen a trillion, 100 times years from now. And the last one will happen 10 to the 32,000th years from now. So what is a black dwarf supernova, according to this fellow's theory? So when stars slightly heavier than the sun leave behind a white dwarf, eventually those white dwarfs will cool off and they'll become black dwarfs. Our universe isn't old enough yet to have any black dwarfs anywhere in it. The universe is only about 14 billion years old, and it'll take a white dwarf probably 100 times the current age of the universe to cool down significantly. That's one of the reasons that these black dwarf supernovas aren't expected to happen for such a long time. So how do they become supernovas? Well, according to this fellow's idea, nuclear fusion can still happen even in a cold core of a star through quantum tunneling. It'll happen slowly, but it will potentially still happen. A tiny, tiny bit of energy generation leading to an iron core. And that iron core will become more dense than carbon and nitrogen. Remember, I said white dwarfs have carbon, nitrogen, and oxygen nuclei that comprise them. Well, if it generates a significantly large iron core, that'll leave a gap between that core and the outer layers, and the outer layers could smash down. And that smashing down would again generate a shock wave that could blow the star to smithereens. So this is a type of supernova that nobody else has ever predicted. And if it is confirmed, this fellow who came up with the idea is certainly entitled to a Nobel Prize. Problem is he'll have to wait a trillion years in order to receive it.
Postmortem.
Yeah.
Or
All
postmortem.
right. One other quick thing before I open it up to further just general conversation. This is a picture. Let's see if I can zoom in on this. Can you still see my screen?
No.
Looking at you.
Let me make sure. Let me share again.
Okay, that's cool. Tornado.
Yeah, so this is a tornado coming from a cumulonimbus cloud. But the cumulonimbus cloud in question is actually a cloud generated by a forest fire in California.
Ooh,
Oh,
cool.
So it's a thermo, or what is it? A pyrocumulonimbus cloud. And out of that cloud, you see all the dark orange. That's because of all the smoke. For the first time in the history of the National Weather Service, a tornado warning was issued for a tornado generated by a forest fire.
Wow.
do you know what level it is?
I didn't see anything about that. I don't know if it doesn't look that big, maybe an EF2. So no, I don't know the answer to that.
I was just wondering, with climate change and the advent of what seem to be additional fires, whether this phenomenon will occur more and more often.
It's a good question, one I don't have an answer to. But
Yeah, it's very possible, I would think. California, the last week or so, has been having record heat waves again. And I lived out there for years, and usually in the Bay Area, the hottest time of the year is September, October, traditionally.
Wow.
The fog in San Francisco stops for a few weeks and everything gets hot. So this is really early in the year for Bay Area to be getting up to 110 degrees in the East Bay, and San Francisco hit almost 100 itself. So it's a couple of months ahead of schedule traditionally.
And the people in San Francisco and the dwellings don't typically have air conditioning.
Yeah, I mean, because you only need it for a couple of weeks a year, and so most homes don't have it. And then Southern California is having really hot weather, and down to the Southwest, and they're having the forest fires and stuff. Southern California now.
Yeah, I saw where Palm Springs had 119 degrees.
Yeah.
But what was really surprising, like Medford, Oregon was like up to 110 or 108.
Yeah.
Wow.
You don't think of Oregon getting that hot.
Well, inland they can, and again, but it's only usually later in the summer for whatever reasons. That's typically when it's gotten really hot, and the currents change, and for a few weeks, and the ocean breeze coming in off the Pacific just sort of stops for a while.
Yeah, the latent heat capacity of the Pacific Ocean is pretty significant.
Once you're on the east side of the Cascades, the Sierras and stuff, it can be really hot. But even in the Central Valley in California, Fresno, Bakersfield can go to 110, 100. I've seen it 115.
Speaking of changes in time frames, isn't the hurricane season on the East Coast advanced significantly this year?
Yep.
Somewhat, yeah.
They've already had some incredible number of named storms this year.
Yeah.
11, I think. Yeah.
Like that.
And I think there's also a La Nina that's happening this year, and that tends to exacerbate hurricane season. So scientists are saying climatologists are saying we're in for a doozy of a hurricane season. Now, whether they hit land or not, it's a whole different thing. Here's I actually have that as one of my news stories for today too. Let me share this picture I got. So this picture shows the typical tracks of hurricanes during September. And as you see, many of them stay out into the ocean, except ones that form in the Gulf, and those often impact the places we're all familiar with.
Yep.
So this is a story today on CNN.
Hmm.
Well, then we had the, I don't think I've seen it and was even aware of it, all the dust storms in the Sierra that got all blown over our way.
Yeah. Well, that happens. So every year there's dust from the Sierra that makes its way into South America. In fact, there are scientific studies showing that South America plants get a lot of their nutrients from Saharan dust.
Wow. Okay, I didn't know that.
And but it was fairly uncommon for that dust to be bent by I don't know if it was a jet stream or some other air currents. It was bent, and so a significant amount of it came up to North America.
I hope it didn't bring a lot of bad creatures with it, bacteria, viruses, etc.
Right. Yep.
Don't need any more of those immigrants.
Hey,
I have a positive story for the week.
okay.
We've been babying in the backyard. We've had bird feeders out and stuff for years, and watching the changing mix of birds and birds that I grew up in Illinois and never saw when I was a kid. But monarchs, of course, have been dying off the last 20 years or more, and I haven't seen a monarch since I was a kid, actually, even moving back here almost 20 years ago. But we've been babying this one milkweed plant that popped up in the backyard, and it got blown over one day with a storm and propped it up again and everything. But it's actually a couple of monarchs have been around this week.
Oh, wonderful.
Yeah, and hummingbirds as well, but the monarchs were the first I've seen in years. So there are a few left.
Wow.
Nice.
I had some stories queued up about the derecho as well. That the linear storm that came through earlier in the week. One of the story just very briefly said that meteorologists remain unable to forecast when a derecho will happen. They're essentially the butterfly effect. A tiny change in a small portion of the atmosphere can lead to a sort of a domino effect that causes a derecho, and meteorologists don't have the data resolution to be able to spot those small scale changes and thus predict when a derecho will happen.
Yeah.
What is it exactly, Scott? Could you describe it?
A derecho is a line of, think of it as a linear hurricane. So typically it happens whenever the atmosphere is loaded with super humid, warm air. And if you get a colder front moving behind that, it'll lift that less dense air up above the cold front, and that's when it condenses into thunderstorms and whatnot. And that's the usual mechanism for getting thunderstorms is a high pressure system moves under a hot low pressure system and causes condensation and a release of energy. But that can lead to a kind of a domino effect where you've got an incredibly long storm front, and the downdraft in front of that front can reach hurricane speeds in terms of air velocity, and those are called derechos.
Thank you.
The one that I remember the best happened in upper Minnesota in the Boundary Waters about 30 years ago or so, 25 years ago. And it almost looked like a Tunguska level event. The pictures of the Tunguska event with trees just leveled for miles. Well, that happened in northern Minnesota a couple of decades ago. Our friend Jack Seacrest and Perry were actually camping in the Boundary Waters when it happened. And trees, they said trees were just snapping tents of campers were just, you know, uprooted and thrown about. There were there were many injuries. I don't remember if there was any deaths, but it left the boundary waters, which was full of pine trees and whatnot, looking like a bomb had hit it. And what we had this week was another derecho, but it was most powerful in Iowa. We call it, my neighbor gave it a great name. Here at my house and in my neighborhood, we call it the Great Storm of 3:15 to 3:30.
Yeah.
Because one of the characteristics of a derecho is that it's very fast moving and it can persist for 1,000 miles or so.
Yeah, I was just reading, like you said, it hit Iowa, it hit Cedar Rapids terribly. I think they said every building in town was damaged.
Well, they still have 100,000 people without power, I think.
Yeah, too.
Wow.
Yeah. I have
Wow.
a friend that lives out that way, and he was east and a little south of there. He said, yeah, they had a lot of trees down. They got out and cut them up, and they were without power for a day or two, but not like some of these other people will be out for weeks probably.
Bob, I see you were in the waiting room. It took me a while to notice you and let you in. Are you there with us?
I'm here.
Oh, good. All right. All right. Well, I'm happy to continue talking for another, 20 minutes or so until the half-hour mark. But I'm pretty much out of stories that I had to share. So anybody else? Oh, there was something about llamas. Did any of you see the story about llamas and COVID?
No.
Okay.
They spit
Well,
on you,
yeah. So let me share this. So llamas apparently generate a kind of antibody, micro antigens that are not produced by human beings and other primates. They're called the nanobodies. So they're not just antibodies, they're nano antibodies, tiny little antibodies that have been shown to have a positive clinical effect in fighting existing COVID infections. So it's not a vaccine potentially, but it might lead to some treatment of COVID and 19 and other coronaviruses. So I'll paste this story in the chat for our meetup here, or our Zoom, and you can all check it out.
So I've been told, I haven't experienced this, but I've been told that if llamas don't like you, they'll spit on you. So
they may even do it if they like you, they may still spit on you.
Well, I had just heard the reverse part of that.
Yeah.
But so I guess if you wanted to get kind of some sort of a surface inoculation, go upset an old llama and stand in front of it and get it upset with you, and you'll develop some kind of immunity.
Yeah, we talked about this story yesterday on Sidewalk Science, and we had the biologist professor, and I asked her if she thought it would make sense for us all to start, in addition to having cats and dogs in our house, if we should all just get a pet llama.
Well, you don't want to get him too angry. He might get pissed off instead of spitting on you.
Yeah, not just spit off, but pissed off.
Yeah. Or people will misinterpret and they'll start spitting at each other.
There you go.
Well, I think they already do that, but I'm not sure.
Too many.
I think that probably all, since they are, I consider them more, how long have they been domesticated?
Long time.
Long time, yeah. They're the only domestic animal of South America. So Aztecs and Incas especially.
And there's two very similar species down there. It's interesting that only the llama have, but I think some of the others, there's the vacuna and I think they have like mohair kind of a coat, and it's harvested. So I guess there's some value there. But the other one is the guanaco, and I don't know what they do.
Are llamas and alpacas closely related? Does anybody know?
They're all very similar in configuration.
Yeah, I know they're related.
They all live in the
camels.
same area. They pretty much all live in the same area.
So that's an interesting story about evolution, that camels and llamas are close relatives, from an evolutionary perspective. And they evolved from a common stock that existed before South America split off from, I think, Gondwana, one of the supercontinents.
So I would imagine that the genetic differentiation is just enough between the llamas and the alpacas, et cetera, that the llamas get the nanobodies.
I don't know. That's a good question. I don't know if camels and alpacas get nanobodies or not. I'll look that up. I don't. That's a great idea. Another news story I had queued up, if we had time, was the world's oldest bedding was found in a South African cave. So some of the most extraordinary discoveries related to early hominids, including Homo sapiens, comes from South Africa. Sea level rise has covered up some of the caves that were likely used by some of the most ancient organized bands of human beings known to have existed on Earth. They typically lived on the shores of South Africa and made their livelihood from fishing and then hunting, etc. But in a cave in South Africa, they found evidence of a bed where grass had been laid down on top of ash. So the thought is that the ash helped keep bugs away. And then grasses were laid on top of that to make a bed. And that was 200,000 years ago. Somebody was sleeping on a bed in South Africa.
Another astronomical thing, I don't know if people have found, but the SETI organization has, during the last few months, has been doing about every 3 or 4 weeks a Zoom talk with a scientist. And they've got one this Wednesday night again. Because it's Pacific, they tend to be evenings, so it's a little late. It's like 9 o'clock for our time, I think, usually.
Could you find the link to that and post that in the chat? I'd like to know.
Yeah, I can definitely do that. But they've got one on the next Mars rover that's going to be sent up. So each talk is on something astronomical, but this week, Wednesday night, is on Martian search for life. So
fantastic.
Yeah, they put them on YouTube as well afterwards, but they're really interesting to listen to.
I was on a Zoom presentation yesterday, and the person that was hosting had gotten a picture of Earth. I think it was taken from Voyager, and I think there was like 2.5 billion miles from Earth. Maybe my figures, but it was a long, long ways. But it showed Earth just as this little teeny tiny dot in this expanse of black. And it was really quite an impressive photo. So I thought I'd share that with you.
Yeah, they've taken several of those. The first one was from Voyager and was requested by Carl Sagan. And
that's the one I'm talking about.
Yeah, the pale blue, it has a name. It's called the pale blue dot image.
Yeah, yeah.
Speaking of images of outer space, I got some of my new astrophotography gear to work this week. This is a picture I'm sharing of my that I took earlier this week of a supernova remnant up in the sky. So I took this from my backyard, my light polluted backyard, shows these tendrils of gas wafting among the stars.
Must
left
have a
over.
pretty good telescope.
Yeah, maybe some other time I'll go into some detail about it, but
Is that considered a nebula?
yes, absolutely.
Okay.
So that might be kind of an interesting presentation, is what happens with all this material that, obviously it drifts apart or coalesces or.
Yeah. Apologies for my dog. Yeah, so the short answer, I mean, we could certainly talk a longer time about it, but the short answer, Bill, is that it becomes you and me. So nearly all of the atoms in all of the molecules of Earth and all of its organisms originated from an exploded star. Otherwise, you couldn't get those atoms outside of a star into things like planets. So stars blow up and seed the cosmos with heavier atoms that then get incorporated into later generations of stars and planets.
Yeah. So material never does actually ever go away. It just reconfigures.
Well, that's unfortunately, I wish I could say that were true and that the universe would be eternal and constantly recycling, but unfortunately, that's not expected to be the case. So eventually, stars will run out of material to form new baby stars, and there will be no new stars in the universe. And the stars that exist, every star that exists today and every star that will exist in the future, has a finite, if extraordinarily long, lifespan. There will come a day or an epoch when scientists expect that there will be no stars shining in the skies of the universe. And that's for several different reasons.
So this question, I have a question about that. I'm not sure if it's quantum entanglement, but isn't there a subatomic particle theory that claims that there are particles that wink into and out of existence, so to speak?
Mhm.
And
Yeah.
is there any tie between microparticle physics and astrophysics in terms of what we're just talking about?
Yeah, so there's a couple of ties that I know of. One of them is that black holes evaporate, and the evaporation of black holes is because the gravity around a black hole is so strong, and this is colloquially conveyed, right? You can think of it this way, but the details are quite complicated. The gravity of a black hole is so strong that it can squeeze new material out of empty space. But in order to compensate for that, the black hole loses mass and size. So the conservation of energy still applies. But you can turn a black hole, which is featureless, into a stream of particles which have an identity, like protons, neutrons, and electrons. But it takes a super.
Has there been any modeling?
Yes.
Go
Yeah.
ahead.
So Stephen Hawking is the one who discovered this likelihood. And it's a likelihood because the lifespan of a black hole, especially a cosmologically or astronomically significant black hole, like from a star, the lifespan of a star-sized black hole is quintillions of years. So much older than the history of our universe. So the amount or the rate with which it squeezes particles out of empty space is incredibly feeble. So that's not a significant source of new material in the universe. And even if it were, the material that it would be generating can only equal the mass of that particular black hole that's evaporating. By the time black holes have reached the point where they are the main source of particles in our universe, the universe will have expanded to the point that it'll essentially be a very rarefied plasma, and those particles are not likely to come together to congeal into new complex things like stars and planets. That's the first answer. The second answer is a very intriguing idea from Roger Penrose. Roger Penrose is a polymath, mathematician, and physicist from Great Britain, probably one of the smartest living human beings, in my opinion. And he came up with this idea that at the end of an epoch of darkness, the universe will look a lot like the universe looked just prior to the Big Bang. In fact, it may be indistinguishable from the initial conditions in which the Big Bang occurred. So his idea, which is not commonly accepted, but hopeful and poetic at least, is that in the far, far distant future of our universe, it will become so rarefied and dark and empty that it will become a womb for a new universe to be birthed from.
Okay. Yeah, I think I heard that before.
So those are the two ways that I know that quantum mechanics and cosmology can relate. There are many other ways that quantum mechanics relates to astronomy. Every star that generates energy through nuclear fusion is taking advantage of quantum tunneling, so that the rate at which energy is liberated from a stellar core is primarily driven by the rate of quantum tunneling. So the most microscopic processes possible in the universe dictate the structure and metabolism of the largest things in the universe, aside from supermassive black holes, which are, giant stars.
Fascinating.
Yeah. Anybody else have any thoughts or questions?
Something that's pretty fascinating is that Bob Bahari is on twice on your screen. How did he do that?
I don't understand it. I just see myself once.
Could be the effect of Scott talking about black holes. New matter has been created.
Oh, yeah.
The action at a distance.
Maybe one of them is his evil twin. Anybody else have other questions that they thought of or curiosities? Well, it's been really great to see you all.
The link to SETI, the new Zoom.
Oh yeah, thank you for that. I'm gonna try to join that.
They do want you to register beforehand, but they do post them on YouTube afterwards as well, as I recall. So.
Okay. Yeah, I encourage all of you to look at your chat window for Zoom and find that link that Stan posted there about a upcoming SETI talk.
Yeah.
Okay.
All right.
For those that are totally inept, could you put that on email as well?
Yeah, I'll ask Mike to send that out. I don't have access to the Science Sunday email list. My opinion about that is that unless I have a need to know somebody's personal and private information, I don't want to know it. And so I don't know any of your email addresses. But Mike Winter does maintain a list of email addresses for Science Sunday, and I'll see if he will send that out.
If you just, I'm sure you could find it if you just go to their main webpage, SETI.org.
Well, that's true. I can do that.
Then you can get on their mailing list like I do, and you get inundated. One side note, I first discovered SETI 20 plus years ago because they were the first organization that came up with the shareware idea that basically you could download an app to your laptop or desktop and help them calculate and run statistical analysis on radio signals. And so for years I had the app, and you could watch the wave calculations and stuff going as they were trying to find anomalies in all of the radio transmissions they were receiving from Arecibo and Puerto Rico and stuff. But this past year, they've actually discontinued that. Lots of
really?
others, yeah, they basically ran out of data. And,
wow.
And said, yeah, and now computers are so much more powerful, they don't need to enlist tens of thousands of people worldwide to do that anymore. But there are so many other organizations now that have enlisted users the same way. You can, run it on your spare cycles on your computer at home, and
including COVID, right?
Yeah, protein folding, all kinds of different. There's dozens of them out there now. But SETI, which was the pioneer for it, actually closed down their service this past year. But they still are out there hoping, and they're trying to coordinate with NASA and everybody else. They're still continuing their mission, just not that way.
My opinion, and this is one of the few things that I have faith about, with a complete lack of evidence. And my opinion is that life is abundant in the cosmos. I think that's plausible, given what we know about chemistry and biology. So I wish them luck. One of the things I have no idea about, I have nothing but hope, I don't have an opinion, is that intelligent life might exist somewhere else in the universe. There are so many impediments between simple biology and complex intelligent beings that have access to technology, that so many walls between those two ends, that I have no sense of the plausibility of essentially the Drake equation. What's the chances of intelligent life? Maybe we're it. Maybe we're it for the galaxy, for our galaxy.
If this is the definition of intelligent life, I'm not sure if we found it.
Yeah, right. Yep. All right. Well, this has been a very intelligent conversation, regardless of what some of other humanity's gotten themselves up to. So I thank you all for joining. It's been delightful. It's nice to stay in touch with you all. And
Thank you.
Thank
you. Thank you very much.
Take care.
Scott.
Yep.
Bye.
Have a good one.
Yep.
Thanks.
Be safe, everybody.
You too.